All set.
Hello,
Hello,
everyone.
Sanjeev.
Hello. If I were to ask you what is hot in tech these days, your response could be data sharing, integrating silos of data in real time, serverless computing, maybe hybrid multi-cloud, even blockchain. Now, if we created a Venn diagram of all these topics, you may be surprised to find out that there is one company that actually sits in the middle of this Venn diagram, and it is called Vendia. Vendia is this exciting startup that is taking the concepts of decentralized permission blockchains to help B2B share data in real time across cloud providers. If all this seems magical, you're in for a great treat because today we have Dr. Tim Wagner. He is the inventor of AWS's serverless framework called Lambda, and he joins us today to get into the topics that some of us data people don't get a chance to get into often. So with that, Tim, very warm welcome to this episode.
Thank you so much, Sanjeev, and thank you for having me today.
You're very welcome. It's our pleasure. So, Tim, can we get started with your background and some introduction as to where you've been?
Absolutely. I'll give you maybe the last couple of jobs because I think they kind of read directly on what we're up to here at Vendia. I spent about 6 years at AWS, as you mentioned, started what's now known as AWS Lambda, was sort of ran the serverless compute unit there, which also included the managed API service, API gateway. But Lambda was the one I started kind of from scratch. So I was kind of employee one there, kind of came in with this idea of wanting to really democratize cloud access. Because if you kind of roll back in time to sort of 2012, the cloud is really the province of a fairly small number of people who really know how to turn raw infrastructure into the things we want today, right? A scalable, fault tolerant, kind of easily managed application. But that wasn't particularly easy to accomplish back then. And so we had this vision of how could we let more developers get access to the public cloud capabilities, faster and more readily. And that's ultimately what drove a lot of this idea behind serverless, as it eventually came to be called. So I was there for about 6 years, ran those two businesses. Now it's a fairly substantial, portion of the portfolio there at AWS, and then went down to Coinbase. Was a VP of engineering at Coinbase, really in the days where we were trying to get the company ready for its IPO. So growing the team, but also working on things like compliance, like data analytics, like regulatory data sharing to make sure that we were kind of ready for that. And that gave me, we'll talk about the relationship to blockchain and crypto here in a second, but it gave me this wonderful ringside seat into what really was one of the largest regulated fleets of distributed ledgers running on US soil at the time. And all the things that are kind of good about that, and then frankly some of the things that maybe from our perspective here today in terms of using them for data and data storing in enterprises, maybe not so good. So we'll get into that, I'm sure, as we start to chat here.
That sounds great. So we have a lot of questions to cover. So let's get started. You mentioned, blockchain. So blockchains have been around for a while. Some of us think of blockchain in terms of crypto or mining. How are databases and blockchains related?
This is one of my favorite kind of topics to chat about here. A lot of people, when they hear words like blockchain or distributed ledger, they do think cryptocurrency, and there really are these two different parts. There's the part of blockchains and distributed ledgers, which are all about consistent data. If you're BMW and I'm Siemens and I'm supplying parts to you to turn into cars, the two of us need to understand, how many parts are you using? How many more do you need? What are your supply chain requirements? And so that type of data sharing need, that search for a consistent source of truth, but across two different companies, two different IT stacks, two different data storage solutions. That's the piece that we get really interested about here at Vendia in terms of sort of the blockchain, the immutability, the distributed ledger component. Cryptocurrencies add into that usually a notion of an on-chain currency. Usually there's a token associated with it. They get into economic incentives. Can it be a self-sustaining ecosystem where people are essentially paid to operate those pieces? And that's sort of the community that gives rise to Bitcoin and Ethereum, and obviously a lot of these kind of newer coins and or altcoins as they're called today. That world today also tends to be a lot about speculation. And one of the things I think has happened there is it's sort of tarnished sometimes this idea of maybe like blockchain as a true, legitimate, and very interesting thread of discourse over in the data community, because this problem of companies sharing data both internally and externally obviously is one that has, occupied the industry's attention for, for many, many years.
So you mentioned this whole supply chain between, a car manufacturer and the car parts. So data sharing has been quite a rage. We were at some conferences where, like, Snowflake renamed their entire data sharing to Snowflake Marketplace. And then Databricks introduced Delta sharing. We see it from different hyperscale cloud providers. So what is different in using blockchain to do data sharing?
Yeah, no, it's a great question. And look, there are some wonderful products out there, especially on the analytics side of the house. I think Snowflake has done actually some really interesting work. And one of the things that's actually incredibly innovative about Snowflake, not just that it's an attractively priced, easy to use analytics system, although it is certainly all of those things. It's also really interesting because it was one of the first products to think about multi-cloud as a feature. And your more maybe application sort of oriented audience, probably has spent time and energy thinking about Kubernetes, which is like build it once, deploy it on 3 different clouds, to kind of go there. And Snowflake had this idea of what if multi-cloud, in particular multi-cloud data sharing, kind of just showed up as something you could get just as a a feature of the product, not as a deployment requirement or kind of a purchasing and operations requirement. And that was really in many ways kind of game changing. We're in the kind of the other side of the house. If Snowflake is sort of the, kind of the serverless OLAP, right? We're kind of over on the serverless OLTP side. And the idea being that, and the kind of the rationale here is think of using a blockchain or a distributed ledger behind the scenes as a really effective way to share and distribute data across different parties. So it is that idea of blockchain more as a distributed database. And in particular, a database where multiple parties can operate on different clouds with different IT stacks and potentially with different notions of security, compliance, et cetera. So trustlessness is still meaningful here. It's not the trustlessness in the sense, sort of the crypto world, right? Of, who owns which coin, but it is trustlessness in the sense of, a desire for a kind of a hard operational and security boundary between 2 different people who nevertheless have to share some kind of data and some kind of information. And that's where blockchains become really interesting, especially when you start thinking about data sharing needs that are real-time in nature, that have strong access controls, and that have to span these challenging chasms like 2 different parties or 2 different clouds. So in case of Snowflake Marketplace, the trust layer has to be built. But so what you're saying is that in blockchain, it is inherently built in. It just comes out of the box. Yeah, it's one of the things that's really nice about having this decentralized relationship, like even with the Snowflake, again, ignoring kind of the analytic versus real timiness of this, you still have a single sort of owner, what a blockchain person would call, the centralized authority, right? Who's responsible for owning and operating the data, and they can choose to share their data. Snowflake's made that part of it easier. What's very hard is especially a multi-writer, multi-reader situation where lots of people want to collaborate on constructing the corpus of the data in the first place. And that gets a lot more challenging. That's where a decentralized system, right, and a blockchain start to be really powerful, because you can combine these concepts of fine-grained ownership on a row-by-row basis with decentralization and with a single centralized source of truth. That's a trick that's still very hard to pull off, in an analytics system where you're really sharing, you're sharing a data set in a very coarse-grained way, and usually with a single identified owner, distributing that data to one or more of their consumption recipients.
One interesting thing that just struck out to me was when you said that think of blockchain as serverless OLTP. I got that right, correct? So,
yes.
Okay, so there is, so I know from what I've read about Vendia, it's also real-time data sharing. There are real-time analytical solutions that are also coming out. We've got things like Rockset, ClickHouse, Druid. There's a new one called Star Rocks that just came out. So we've got like some of those real-time analytical products. We've got OLTP. Then we've got HTAP, which is the amalgamation of OLTP and OLAP into one single store, like a company called Single Store, for instance. How does blockchain-based solution sit in this OLTP, OLAP, and HTAP?
Yeah, no, and it's a fascinating area. I think maybe not everybody even realizes just how databases have kind of like blossomed all of a sudden into this interesting emerging kind of research and also go to market kind of innovation over the course of the last few years. So I would answer that question like by thinking about it this way. There's sort of a classic three-way Venn diagram here, not to riff on the Venn diagram too much. Conventionally, you had an OLTP systems, right, which were all about row-centric, kind of real-time data. OLAP systems, which were often more columnar in their orientation, and really designed to drive analytics and BI, and eventually nowadays AI ML workloads. And then there was this sort of third leg of the stool, if you will, that emerged, which was blockchain, which really excelled at this idea of decentralization, this sort of imposed source of truth across disparate systems, and maintaining that consistency, irrefutability, and so forth. And everybody would love to find the grand unification theory between these three. HTAP is looking, and you see things with, as you mentioned, single store, some of the more recent, like the Unistore stuff coming out of Snowflake, looking at these ways to blend the conventional analytics world with the conventional, operational data world, and see if there isn't some way at looking and maintaining indices and data structures to be able to access that data in those two very different patterns. Similarly, I'd say like Vendia is really focused on this question of, can we unify blockchains with operational data stores? Can we make a blockchain feel like a conventional database through including transactions, dirty read avoidance, all of those pieces, data models that make it feel and operate and look like a database, just one that can stretch across different parties who don't necessarily trust each other. And then there, of course, there's this question of, can you start to add ledgering and more of the decentralized and sharing mechanisms to conventional OLAP, which starts to make them in some ways feel a little more like database capabilities. And again, like you see some of that in the data, the sort of data sharing features of Snowflake and Redshift and others, and some of the work being done there in Iceberg, right? You start to see movement in that direction. So I think everyone is gunning for this, eventually, right? This kind of holy grail of being able to kind of unify all three of those pieces.
So do you see blockchain as a complementary technology to these hybrid HTAP systems, or do you see blockchain taking over the emphasis we've had on relational databases for the last few decades?
Yeah, it's a great question. I mean, I think there is a long term, I think there's a role for several different of these, of these technologies to coexist. For example, right, and if you think about this as a continuum, with say maybe like a public chain like Ethereum on one end of this continuum, and a conventional cloud database on the other end of this continuum, they're probably, on a price performance basis, probably about 15 orders of magnitude between those two things today. Think about paying $50 for, an Ethereum transaction, and the 14 transactions a second it can convert, versus the 100+ million transactions a second AWS's DynamoDB can perform, at a tiny fraction of a penny, per transaction. And then there's a lot of space in between. So I think the centralized technologies, those that serve, especially that serve a single account, a single owner, right, producing and consuming data in their own systems, that's always going to be the lowest cost point, the fastest kind of time to delivery system. Conversely, a public chain will probably always have the highest price point, but the best kind of planet-wide distribution and decentralization. And then sitting squarely in the middle of that are these data sharing solutions that can sit in the cloud, as Vendia does, that are really good at helping companies bridge cloud or organization or partnership gaps together. It can move large amounts of data very efficiently. It can be built in a multi-tenanted way. And really are complementary. And to answer your question, are complementary to classic analytics mechanisms, and can sit alongside of those, because they really, for most of our customers, they slot more into the application side of the house than they do necessarily into sort of the data ops team.
I see. So I just want to repeat for our viewers. On one hand, you've got a public cloud like Ethereum, which does like 15 transactions per second. On the other hand, you've got Amazon DynamoDB nearing about 100 million transactions per second. And then you've got $25 to $50 for Ethereum, and you've got tiny fraction of pennies. In fact, if you do that comparison, it turns out that a single transaction in Ethereum is a few million times more expensive than a transaction in DynamoDB. So that is between the public cloud and a DBaaS. So Vendia sits sort of in between, and it's not using public blockchain, it's using private, correct?
Correct.
Yeah, so I know we were going to talk about Vendia in more detail as we move down in our questions, but can you talk about how is it that Vendia is able to bridge this massive chasm between Ethereum and, let's say, DynamoDB?
Yep. So let's talk a little bit about kind of how bring this other word into our discussion here, and talk a little bit about maybe how serverless fits into this equation. So there are two ways in which we in which we kind of care about serverlessness, if you want to kind of call it that here at Vendia. One of them is just from a pure customer perspective, and we should come back and talk a little bit about smart contracts and stored procedures, and just making those easy to write, easy to use, easy to learn, disjoint from the requirement, for example, to express them in Solidity and so on and so forth. But the other one, and to your question here, and this is the one that kind of matters from the, if you will, the form factor of what we've built here. Conventionally, your audience has probably seen this, right? Like a conventional blockchain was thought of always as a single machine deployment. It's a consensus algorithm, a storage layer, whatever, but it deploys to basically one machine, and that's problematic. Because if you can run Ethereum on your laptop, which you can, it also means Ethereum's never going to run faster than what you can run on your laptop, because it's not inherently a multi-tenanted distributed system in the sense of the cloud services. And that was the idea behind Vendia, was what if we went back to the basics? What if we kind of reimagined this idea of a distributed ledger, not as a machine image running on a single server, but rather as a constellation of cloud resources, and then in particular, serverless ones that would have this property that they essentially evaporate when there's no work to do, but when there is work to do, they can be called, in milliseconds, they can be called into service, they can scale up very rapidly, and have this nice kind of fault tolerant, cost following profile from them. So because we built them that way, we also don't have to scale our customers to their peak capacity. We don't have to worry about what their peak capacity might be on a given day, right? We allow that problem to flow instead to the public cloud, where services like Lambda and queues and blob stores and so forth can kind of float up and down in this very fine-grained way. So I call this the STAMP-T model, single tenanted accounts over multi-tenanted infrastructure, and it's kind of the idea that kind of underlies what we've done. And it's the way that we kind of split the difference here. It lets us give people a blockchain-like experience, but with the cost and the performance and the scalability profile of a serverless public cloud service, something like a Lambda or an Amazon S3.
Very interesting. So basically you got out of the single tenanted blockchain. So the underlying infrastructure is multi-tenant, but the account level is still single tenant. So with that, and then with serverless, and what is a smart contract in this concept?
Yeah, so we've historically, right, in a data for a database person, there's always been this notion of the compute that goes with the data, the stored procedure that interlocks very carefully, right, with what's being done from a transactional perspective. And and blockchains have this corresponding idea of a smart contract, right? That's kind of can be initiated, that is triggered and runs off the information in the blockchain, and then potentially changes, and returns, new updated information to the chain. So it looks really a lot like a stored procedure, but with this concept of decentralization. The piece we've added in here at Vendia is the idea that the smart contract really can be expressed as a cloud function. So, if you have a Docker image, if you have an AWS Lambda function, we can go run that, and we'll populate that function with information that comes on chain, that comes from the stored database here, and that will have transactional integrity. And then similarly, we can return the results with that same kind of transactional integrity, back into this corpus of data. But in Ethereum, for instance, because that stored procedure or that smart contract has to run everywhere, and it has to yield the same results everywhere, it's incredibly inefficient. It's inefficient from a cost perspective, from a time perspective, and also means that, for example, simple things like time and date stamping, a piece of information is essentially impossible because two different machines might come up with a different answer. And so you can't even express that in an Ethereum contract today. And we had a very different take on this. Our take on this was, what matters is that everybody can trust that the function being run is the same piece of code. And then we really trust, we really create that immutability at the cloud level. So, if you can all trust, what that code is, everyone can see the code, and everyone knows that the cloud provider is executing that code accurately, then it doesn't matter who technically owned that particular piece of code. And it especially doesn't matter that you don't run that code, 1,000 times over for 1,000 different participants. You can run it once and establish that same level of trust in what's being executed and the outcome. And that makes a huge difference, that ability to preserve that trust model, but with a radically simpler and more cost-effective execution model.
It's very interesting to see how these what in my mind were disparate technologies, the function as a service, the serverless, and you've got your data persistence layer, you got blockchain. So these are all sort of starting to collide, and you're leveraging these technologies in a very interesting new manner. So yeah,
it's one of the things that's kind of the most makes this a very fun day job, right? Because it's an exciting business to be in, helping customers, but it's also incredibly exciting from a technology perspective. There's a lot of really amazing kind of innovation in all of those areas you just mentioned.
So one of the things that we spend all our days these days is talking about, is it a cloud data warehouse that has the right technology? Is it the lake house? Is it a data virtualization layer? And then, of course, there's the whole of data world has been a fire on data mesh versus data fabric. Now, knowing that organizations are going to have one or more of these technologies, how does the blockchain-based data sharing fit into the ecosystem?
Yeah, it's a great question, and there are, unsurprisingly, there are kind of a few different touch points here. So there is this, you mentioned iPaaS. Gartner has this MQ they call their EI PaaS. Think of it as kind of the Microsoft and Boomi crowd, and that was really this set of integration technologies, generally API based, increasingly cloud based, that companies use to be able to share information, especially inside. I think about it as like the way they can integrate different, ERP systems, for example. But it kind of leaves open this question of, well, how do you share that data outside a company's four walls? And Amazon has this wonderful, Amazon Retail has this wonderful quote that I love. 80% of data now lives outside a business's four walls, which is fairly dramatic if you think about the integration challenge, right? The 80-20 rule has kind of flipped here. So now much of it sits kind of outside there. And that's kind of the piece of the data mesh that we get really interested in here. If you want to use that term, like, we care a lot about real time. We also care a lot about helping customers get data from their partners, in and out of their their four walls very effectively. And that's challenging. A lot of this stuff, a lot of the work around data warehouses, lake houses, data virtualization, et cetera, has really focused on the sort of the back office, right, and the analytics, especially within a company's purview, as opposed to sort of the sharing pieces of that. And it leaves companies with fewer options when they're trying to figure out that real-time kind of operational part of the house. So we love this term real-time data mesh here, like it often, for our customers, right, often speaks to that piece. And then another one we could spend some time talking about here is the connection between those two parts, because the operational to analytics flow, is ultimately it looks like some form of ETL or ELT. And one of the interesting observations here is that if you think about what goes on under the covers with ETL, it's kind of like a little baby version of a ledger, because an ETL system is generally creating a durable store of the primary keys and their status. So it doesn't remember all the information, but it remembers enough to cross-correlate between the operational system and the eventual analytics system that it's transferring to. And so you can think of, in some ways, of a distributed ledger as playing sort of that role, that interlock role, and doing that same thing, except it also has a copy of the data available for it. So it's able to answer both operational questions, provide flexible access patterns, and do some of the integration chore of a classic EI paths, and then also be able to pass and exhaust that information into an analytics store. So we often at Vendia, find ourselves kind of sitting in the middle of that soup, as it were.
I've never come across ETL being called like a ledger of primary keys, but that's a very interesting concept. So now that we're talking about like building out this ETL or ELT chain, so if you don't mind, can we go to the first step, which is the extraction or ingestion of data? So Tim, you mentioned that the recent study show 80% of data is sitting outside an organization. This data could be structured, semi-structured, unstructured. Typically, we use like Kafka, Flink. But in case of Vendia's SaaS offering, how do you get data from various different data sources, and what kind of SLA you have? Because a lot of this data is coming at very high volumes, velocity, and it's in all shapes and forms.
Yeah, no, it is, and we should let's talk about a couple of things there. First of all, like how does that data get in? So one of the things that we do here is well, actually, and this is going to sound very common to someone who's used to hearing about APIs or or thinking about databases and data models, but very unusual from someone who thinks about it as a blockchain. One of the things we do is we have a customer data model. So we'll start from a JSON schema. We'll use that to actually compile GraphQL APIs. So we'll construct an API surface layer that reflects the customer's data model, their specific schema and ontology. And then we'll also use that to kind of customize the back end of the data storage layer and all the other kind of cloud resources that we create there. And then that'll be the basis typically for customers to interact with the system, so they can both read and write data through through those APIs. We also provide them with a parallelization and batching SDK, because as you mentioned, often like this is also a high throughput challenge where you've got either a lot of clients trying to submit either read or write data simultaneously, because this is an operational system at the end of the day. And or you've got a challenge, a latency challenge, right? We have clients who are using this kind of hooked up directly to web portals, mobile apps, et cetera. And so making sure that they can read that data in a very low latency fashion at what we like to call sort of like cloud line rates of speed. So they can basically get data out of that system as fast as if they had built it themselves. And that's important, right? You don't want the use of a system like this for operational purposes to impede the ability to obviously construct an effective, responsive application on top of it. From an SLA's perspective, we offer a 4 nines uptime. That's actually relatively easy for us to do, because we've got this sort of serverless core that a lot of which is shining through in terms of its resilience. And then what gets really interesting, and this was one that kind of blew my mind when I first sort of thought about it this way, is blockchains and distributed ledgers are really great at sharing data between two parties, but they're equally good at allowing a single party to span different regions or different clouds. And that means that you can use them just as readily to create high availability systems as you can to create, decentralized systems. And you can do the same, you can do both those things at the same time. And so we often see that in especially our financial service customers. They will want to share data with a partner, but it is just as important that they be able to establish a regulatory SLA for resilience by going to another region that's at least 200 miles away, for example, to overcome a geographic, like a flood or a hurricane or something, or across two different clouds for similar kind of reliance reasons.
So if I were to take an example, you mentioned supply chain is a very big use case for real-time data sharing. Let's say, I have a manufacturing plant and Oracle happens to be my database. And, as the widgets get created, they go into this manufacturing ERP system. Now I want to do data sharing and I want to put Vendia. So in this scenario, how does Vendia connect to, let's say, Oracle, understand its schema, convert it into JSON? So you were explaining that, and then load it into the blockchain. How does that happen?
Yeah, so it's one thing that's fairly typical when we're working with customers, because they often do have this kind of broader ecosystem or topology at play. So, for example, we're working with some major U.S. airlines who are sharing some of their marketing and sales with alliance partners, and that requires kind of all of the parties to be able to, to ultimately to integrate that data at the same time. And so it provokes these, these challenges like you're describing. Usually there are two or three different ways in which that's handled. Sometimes the connectors to the individual systems. So you mentioned Oracle, for instance, either a database connector, an application connector like a Salesforce, for example. Those will typically have, what get called kind of, lightweight ETL or kind of real-time ETL, where there are modest transformations, usually happening on a row by row basis as that data flows, into the system, to us, or out of the system, kind of back into those, those other systems of record. And exactly how this happens, depends a little bit, will vary a bit from kind of connector to connector. But just like an iPaaS system like MuleSoft would have its data weave, we have a similar type of transformation language to express and control some of those capabilities. There is also the fact that we're usually, because we're serving as this single source of truth, there's this very kind of well reified, data model, right? This data schema that, that mediates all of the partners and players, and the thing that allows us to create these APIs that are able to do, data fidelity, referential integrity, kind of all the classic database checks, such that the data coming into the system, once it hits Vendia proper and gets shared and distributed at the by our replication and consensus layer, that it accurately maps into that schema. And that's obviously super important, right? We need to be able to fund these APIs and create this single source of truth. And if you didn't have data integrity or a shared schema in the first place, that would obviously be challenging. So, some of that happens at the connector layer. Some of it happens during transformations in our system. And then the third kind of way people do this is it's not uncommon to stage information either as a file or as kind of preliminary data, and then drive smart contract-based workflows inside the system to further transform that data. And that often looks like things like policy enforcement and enactment. So think, another use case for us, I think airline ticketing, right? So you fly into sort of a terminal, then you fly out of another terminal. There's this federally mandated minimum time to be able for a human being to transit from, one terminal to another within the airport. That policy has to be followed by all the airlines and across airline interline bookings as well. So it's like the perfect example, the type of thing that takes place once those tickets exist and gets checked inside the system to ensure that, all those compliance and other kind of regulatory requirements are being met, and can place an automatically adjust a ticket or cancel it or whatever it needs to do if one of them isn't. So it's a very, very typical way in which there's this kind of post-entry transformation or policy enforcement that can occur on top of the data to create those additional levels of fidelity.
Since you mentioned the airline use case, so I'm also thinking, this is what you just said is super useful to get a grasp. What is the the business use case for the airline example you gave. And the reason I'm asking is because in my mind, I'm moving down the chain. So we talked about ingestion. Now I'm talking about thinking transformation. And I'm also thinking that typically when I do data sharing, I'm getting data from multiple sources, transforming it into a unique view. And so in this example of airline use case, how many data sources are we talking about? Where in this pipeline is that integration happening? And where can I go to see the lineage?
Yeah, it's a great question, and the airline industry is just a wonderful example to talk about too, because the things are generally more visible, right? Like it's a human being who is doing some travel here. So as opposed to say a financial transaction for mortgage servicing behind the scenes, or a widget being turned into something else in a manufacturing process, with airline travel, it's a person kind of moving through the sky. And often there are obviously this varies with sort of the flight and the ticket and everything else, but there are obviously a bunch of different parties here that generally have to collaborate and share information to make this succeed. Let's say I fly from Seattle to Nashville, and I've got to travel in two different airlines. I've got to go through maybe Chicago or some other city in the middle. Now I've got what's called an interline ticket. So the ticketing agency has to care about it. The two different airlines have to know about, the fact that I'm going to be traveling on them. But it's not just that. There has to be a record at the airline level. The federal government has to know. The mechanics for those airlines, right, have to make sure that those airlines are flying with an appropriate manifest of parts and servicing records. After the flight's complete, a financial settlement agency like Airline Reporting Corporation, or ARC, is going to have to take the ticket price that I paid and split that up to several hundred different people who, at the end of the day, who are going to get, their tax or their ticket costs or whatever else it is, and on and on and on. So it's that one flight or that one trip that I take might turn in, over the course of time, into dozens of different systems and organizations and different legal entities that ultimately have to know about my ticket, my travel, and all of the bits and pieces that were involved in making that happen, correctly, safely, and obviously in a compliant way with respect to, travel regulations in the U.S. And then if you fly internationally, you can imagine you add a whole another layer of of sort of security and challenge, onto that. And that's where kind of Vendia gets involved, in sharing that ticketing information, enforcing things like ticketing policies and so forth. On the back end, processing financial settlement as that ticket gets distributed into different pieces. So there are a lot of these opportunities in the financial services and travel worlds, right, to participate in these interesting multi-party, multi-workflow transactions that are constantly occurring
in real time. Is this happening in real time?
Yeah, that's one of the things that is that's been really interesting, because the shift in general in this industry from batch to real time has been super important. You can imagine this, easily on the cost side of the equation, right? If you can't settle the payment on the ticket for a month, that means somebody has to be willing to kind of carry that balance on their sheets, for a month of time. And then if people can't agree on the details, there's a human mediated process, and those remediations are incredibly costly. So getting rid of human remediations, driving that toward automation, it's a classic IT automation play. Lower cost, increase efficiency, reduce kind of, time to outcome. What's really interesting, and maybe a little less obvious, is the top line consequences here. Because if you're an airline, one of the things you'd love to be able to do is have real-time traveler information in order to be able to do things like dynamic pricing. So you could imagine, for example, if I'm traveling for my company on business, and I already have several people who are going to a particular destination, an airline might offer me a discount on an additional ticket. Say like, hey, why not fly one more person? We'll give it to you for half price. But you can only do that if you happen to know that those other people are traveling, when they're traveling, what they paid, kind of all of that information. And so shifting from batch to real time helps the industry not just lower costs, improve automation, get better customer outcomes. It actually opens up some of these really exciting new pricing opportunities and revenue opportunities that that don't exist if you have to wait 45 days to learn who traveled where.
Yeah, there are in this process of building out this pipeline, this I have a bunch of questions on data governance, data quality, but maybe we can park those in and come back to the if you have time. What I'd like to know is how do you do analytics on this? Like, is there a knowledge graph that's sitting on it? You mentioned GraphQL. How do the APIs work? So can you talk about the analytics part?
Sure, and some of this will depend on the specific customers. So they really kind of fall into a few different categories here. There's some customers who they're already users of, say, like a Snowflake or a Databricks or or a Redshift, and so then our role becomes essentially playing that sort of built-in ETL, if you will, right? We're going to do what maybe they'd be doing with other operational systems with a product like Fivetran, and taking the operational data and shifting it directly into their analytics system. And then they'll use that as a way to kind of drive more of their analytics workloads. The other thing that we've heard a lot from our customers is a lot of them want this lighter weight real-time analytics, directly from us, which requires these new access patterns. So they don't just want to call an API. They don't just want to retrieve data. They'd like to be able, for example, to do ad hoc SQL queries against us to aggregate and analyze the data kind of as it occurs, sort of in the moment. And so one of the things that we're working on now to bring to market is basically a SQL alternative to the GraphQL APIs, so that customers get that choice of access model, right? If they're building an application, they'll access it through the API. If they're building a database, they can access it through that. And then the third piece here, one of the things that we built in a long time ago was this, based on this realization that customers always want fine-grained data access, but where a lot of them are today is files. And a lot of data sharing, really, honestly, is still SFTP file sharing at the end of the day. We mentioned the airline industry, for example, right? Like a lot of that ticketing and passenger information really still comes in the form of, of files that get passed around. And so that's the third piece of this, because customers will sometimes drive their analytics workflows off a file-based approach. And because we've built in things like, for example, for an AWS node participant, customers will be running in AWS. We'll give them an Amazon S3 bucket to store their files. And that makes it really easy for them to drive some of their analytics processing directly off of that, especially if they have a data ops team that prefers to do file-based manipulation. Maybe they're kind of more Python pandas based. That becomes a really easy workflow for them. And then, of course, we've got some customers who are just really just love using the APIs. And so they, if they're more application oriented, they're driving typically like a web or a mobile experience, and they're doing some of their own analytics, aggregation, and kinds of other, display oriented reporting on that, directly off the APIs themselves.
Typically, when you are working with your clients and deploying a solution based on Vendia, how much time, like how long is this deployment, the whole build and putting it into production, and what skill sets are needed to deploy a solution?
Yeah, it's a great question, and and we should talk about a couple of different pieces of that. One of the so let's start with the thing that's kind of like the best part about this at all. So, if you were to walk up to an Oracle or a cloud database like Amazon's Aurora, and give it a create table statement, within a few minutes, for some of them, maybe within a few seconds, you're going to have a production grade database kind of ready to accept data and, and start operating for you. And we designed Vendia to be much the same way. So you can kind of walk up with this JSON schema, which is your data model, hand that to us. And, in under 10 minutes, we've got, for even across different clouds, different regions, different customers, a production grade, highly scalable, fault tolerant system ready to start accepting data, with API endpoints, file support, and and everything else. So the nice thing about that is, that part of it can be incredibly fast, literally like in minutes, as opposed to, say, the typical 6 to 12 months to go deploy something like Hyperledger Fabric or or Quorum in maybe a more traditional server-oriented data model way. And that's in part because we've designed this from to be kind of SaaS and cloud-based from the get-go. Now, 10 minutes sounds awesome, but you and I both know that at the end of the day, the part about this that's hard is also coming up with a shared data model. It's also doing the integration, as you asked about earlier, to existing systems of record, or to analytics stores on the back end. It's making sure, and over time, also not just, it's never the data model, right? It's always an evolution of a data model. And so making sure that the application teams are capable of actually not just standing it up, but then changing it over time. So we do everything we can by virtue of making the SaaS to lower that operational burden. We also built in something we call schema evolution, make it really easy for people to add fields, add new object models to their existing schema without having to take it down and without having to, export and re-import the data, all over again. Because really, this is an operational system. Changes like that can't be done, in kind of a batch or heavy-handed fashion, right? They have to be done keeping the system up and alive and responsive that entire time. So we've tried to reduce the set of skills here, like just first of all, reducing the operational burden, making it easy for folks who don't know anything about blockchain to basically get this ledger-like experience. And then, especially on the smart contract side, folks can write in their language of choice. They can bring their own Docker image. So there isn't this requirement to go off and learn a somewhat arcane language like Solidity with all of its rules. Instead, they can, just get started with their existing business logic and be able to do the things that they're already comfortable using today with the tools that they're already using today. And those have all been, I think, for our customers at least, have been game changers, right, in terms of getting solutions to market very quickly on this, as opposed to maybe a more conventional blockchain deployment timeline of 6 to 18 months, and usually a few $1 million for a team of 15, 20 people who are going to be required to stand all of that up.
Is there a no code or low code development environment with Vendia?
Yeah, one of the things that we offer here is this developer portal that makes it really easy for customers to enter their schemas, perform queries against the system. And so the nice thing about it is all the core parts of what we do here, API stand up, the data storage layer, the consensus pieces, no code's required to implement any of that. And then one of the important things that happens, of course, because we're talking about decentralization and multiple parties here, it's very frequent in one of these use cases that you're going to go invite an additional party. Maybe an airline, for example, adds a new alliance or loyalty system partner, right? And so they need to bring somebody else into the fold, as it were. So we've tried to make experiences like that essentially no code activities. Basically, if you can send an email to that partner, we have a secure way of now adding them to the system. And what would normally look like, weeks or months of, deployments and coding and stand up, for example, all happen behind the scenes. We'll spin up those new resources, populate their databases, and get their APIs ready to go. And so that becomes a very easy operation. And this is something that's kind of allowed us to make our customers a lot more productive, because, otherwise they'd have to go devote, whole subsets of their IT staffing in order to pull something like that off.
So my next question, if you don't mind, because this is sort of a new space for me, and I'm still, wrapping my head around it. So my question is, if Gartner were to do a Magic Quadrant on Vendia, what category would Vendia fall in? Yeah,
it's always a hard one, and I'm laughing here a little bit because this was something like back when we did Lambda and the serverless stuff at AWS initially. The big question with Gartner was, but which MQ does it fall into? And it's always a little challenging. What we've done here does sit at this nexus point of APIs, blockchains, and databases. And so there are aspects of Gartner's EI PaaS in here. Gartner doesn't have a blockchain or distributed ledger, but that would be another kind of obvious one. We touch on ERP systems, but we don't try to be an ERP system. And then obviously we spend a lot of time dealing with data, but we ourselves are not a trying to replace or disrupt necessarily existing cloud databases. We build and layer on top of those. So probably the single best categorization would be a kind of a smart multi-party transaction monitoring system. That's not really a term of art that that exists kind of in Gartner's world today. Back oddly enough, a long time ago, right? Tibco and others like kind of had a product category like that in the sort of the pre-cloud era. And that's probably the thing that this would be kind of the most like. So I would imagine from Gartner's perspective, probably if they were to construct an MQ, distributed ledgers in some way, shape, or form, or data sharing, in some way, shape, or form would probably be the thing that would, this would look like.
So I have, yeah, that's interesting, because when I was in Gartner, my second piece of research was on blockchain. My second document, when I joined Gartner 6-7 years ago, I was like, I was bitten by this whole idea of blockchain, but then I didn't get that many client inquiries, and I sort of backed off that topic, and I never looked into it. But
I'm sure you've seen Gartner's, the hype cycle for blockchain, right? And certainly the pit of despair there,
yeah.
right? That trough of disillusionment was a real thing. I think blockchain came on strong with this amazing promise of, hey, what if you could replace all the complexity of building, a complex partner integration system, right, with something that could come off the shelf as a platform, and then failed to deliver. The scalability wasn't there, the fault tolerance wasn't there, the enterprise integration and deployment, wasn't there, the data modeling wasn't there, support for files, all these things that a real company needs to get real work done. So it's funny, like we sometimes say with folks who are excited by blockchain, we'll talk to them about distributed ledgers and blockchains and how this is a next generation system. Other customers, we don't use the B word, if you will, at all, right? We talk to them about the use cases, the data sharing needs, right? The partners that they have and how they work and communicate with those partners. And honestly, some of those customers don't care how it's done. Distributed ledger, database, cloud, whatever. They're like, hey, all I care about is that my data gets shared effectively, consistently, and timely, right? And you guys do what you need to do to make that happen.
Yeah. High performance, cost effective, and
yep.
resilient. So I want we only have 5 minutes left. So I want to talk to you about something entirely different, not to do with technology. I'm curious, what was a spark that made you start thinking about serverless at AWS? And if I may, what is the spark to start Vendia?
Yeah, and there's obviously a bit of a thread here between these two. Like one of the things that's made me really passionate kind of throughout my career is this idea of democratizing access to technology. And I've kind of tried that in different ways. I've worked on open source, I've worked on IDEs, trying to make things easy, code easier to write, easy, libraries easier to share. When I arrived at AWS, the cloud really was this province of, relatively few experts who could figure out how to turn raw infrastructure into these production, highly available systems. But it kind of left the other 99% of developers, without this obvious way to get some of that immediate value of the cloud, how you could create a, 4 or 5 nines uptime system that was scalable and multi-region and all these other pieces. So AWS Lambda, what that kind of, that serverless idea eventually became, that was a reaction to that. And it was this idea, probably AWS is, one of their first attempts, so certainly not their last, to take those complicated ideas of operations and scalability and shift them from the application developer back onto the cloud service provider. And, in some ways, now you can see that at, like SageMaker and Aurora and Redshift, they're all doing it there. And in some ways, Vendia was a very similar idea. The challenge of building a high speed, high throughput, multi-party, consensus-driven data replication and consistency engine, it's a really, really difficult technical problem, but it's a problem that can then basically work across any industry and many different use cases. And so it's a perfect kind of platform opportunity here, right? Like a lot of people can take advantage of it, but most of them don't need to actually know or care how the underlying details, ultimately work. And so we got very excited in democratizing that in exactly the same way, and very frustrated by the fact that, the existing blockchain, the sort of first generation technologies, if you will, for it, none of them were doing that particularly successfully. There's just too much of a focus on things like, speculation and, Bitcoin and so forth, and very little focus on, say, enterprise grade data sharing, right? Which is the part that, that all of us care about here.
Yeah, I think I seem to remember many years ago, Andy Jassy said, if I were to do cloud all over again, I would make it all serverless.
Yep.
That was his statement. And I saw Redshift, the data warehouse offering, went serverless. GA went serverless went GA 2 weeks ago. So
I still remember the day I looked Andy in the eye and I said, one day, Andy, everything you make is going to have a serverless aspect to it. And at the time, I don't know if he believed me, but but I think now in retrospect, that has kind of come true.
Yeah. So if people want to learn more about Vendia, where should they go?
Yeah, they can go check out the website, www.vendia.net. A good place to kind of learn more about use cases, some of the products and technologies, or to just go get started and sign up if they're a developer. And then our blog, vendia.net/blog, is a great place to go if the conversation you and I have been having here today is feels like an interesting one to follow up on. We have a lot of topics there, like how are blockchains and databases related to each other? What's the role of blockchains in, say, the financial services industry? So lots of kind of interesting discussion up on the blog about allowing them to explore some more of these topics.
So in the last 1 minute, a question that I'd love to ask guests is, tell us something interesting about you that the world generally does not know.
Well, so one unusual thing about me is I've had some kind of fun pets. So I used to raise squirrels. So I've had pet squirrels that lived in my house, and they're wild, but were actually really friendly and fun pets. At the time, and kind of did some rescue and support and stuff there. So it was an unusual thing to have, but made for some really interesting years while we did that.
How many squirrels did you have?
We never intended to let it get this high, but we maxed out at 6, which is a lot of squirrels to have in one house.
And changing the topic, I think I saw on your website that you're quite an accomplished pastry chef. Did I get that wrong?
I have certainly been guilty of making and unfortunately also eating desserts. So yeah, it's one of the things I think my co-founder is worried I'm bad for her waistline.
With that note, thank you so much. It was such a pleasure to have you on this episode. Really enjoyed. I think there's still so much more to uncover, but hopefully we'll get a chance to do this again. Thank you so much.
My pleasure as well. Thank you so much, Sanjeev.